Alright, welcome to Unit 5 Video 3. This is on the sum and differences using cosine. So have your Video 3 note sheet ready for you and we'll be set to go. Alright, so the sum and difference of cosine, this is what you need to write at the top of your worksheet. We're going to be using this for the entire sheet, so have it available. And the faster you know this, the faster and easier this will become for you. So what's really important is that we have the cosine of A minus B versus the cosine of A plus B, where A and B are just two angle measures. So they can be an angle measure we don't know, like theta, or an angle we do know, like 90 or 30 or 45 or 120, any of those angles. That's what A and B represent. And when I subtract these, it would be lovely to think that I could just distribute a cosine, but that's not the case because cosine's not a variable. Cosine's a function. It has a process. So we're going to have to write this out as the cosine of A times the cosine of B plus the sine of A times the sine of B. And that's the formula for when we subtract two angles. So then I have the cosine of A times the cosine of B minus the sine of A times the sine of B. And I didn't confuse those symbols. For when you add angles, you use subtraction in your formula, and when you subtract angles, you use addition in your formula. That's the way it goes. Have those at the top of the paper, and let's keep going. So here we're going to work these out, and I highly recommend that you actually, for the first few times, write out the formula and then start filling in your values for A and B. Because here our value for A is 0 degrees and our value for B is theta. We don't know what that second angle is. So if I have this equal to the cosine of A times the cosine of B plus the sine of A times the sine of B, then I'm going to have the cosine of 0 degrees times the cosine of theta plus the sine of 0 degrees times the sine of theta. So now I filled in my values for A and B, and now it's time to evaluate. That means I need to know what the cosine is of 0 and the sine is of 0. So if I think back to what 0 degrees is, it's located at 0 or 1 comma 0. So my cosine is 1 and my sine is 0. So now I will replace those. I do not know what the cosine of theta and the sine of theta is because theta is any angle I want it to be. So since it's still a variable, I've got cosine of theta and sine of theta remaining in my formula. For a final answer of, well, 0 times anything, so this gives me the cosine of theta as my simplified answer. Let's try that again with the cosine of 0 plus theta. So if I write this out completely, I get the cosine of A times the cosine of B minus the sine of A times the sine of B. And I start filling in my values. The cosine of A is 0, the cosine of B is theta, minus the sine of 0 and the sine of theta. So let's start replacing. Well, I'm still using 0 degrees here and I don't know what theta is, so I will end up with 1 times the cosine of theta minus 0 times the sine of theta. So this one ends up turning out to be exactly the same, cosine of theta. So let's try something that might look a little more interesting. I'm skipping numbers 3 and 4. I want you to try those on your own on the worksheet. And I'm going to do number 5 with you. So I'm going to start once again by writing out the whole thing. So this is the cosine of A, cosine of B. I'm subtracting, so I'll use addition. Sine of A, sine of B. And I'll start replacing the A and B with numbers. So I have the cosine, of 90 So I have the cosine of 90 and the cosine of 30, the sine of 90 and the sine of 30. Let's remember we have to find out what those values are. So 90 is at 0 comma 1, and my 30, you can do one of two things. You can know the ordered pair, well, one of three things. You can memorize the sine and cosine of 30 degrees. You can write the ordered pair out to remind you, or you can draw a triangle. These are going to become time consuming if you're always drawing triangles. So the ordered pairs or the just memorization is probably your better options. So square root of 3 over 2 and 1/2 is my numbers for 30. So my cosine of 90 is 0 times a cosine of 30, which is root 3 over 2, plus the sine of 90 is 1 times 1/2 for my sine of 30. So when this is simplified, that one's gone, and I end up here with 1/2. Now a great way to check is that this really represents the cosine of 60 degrees. And the cosine of 60 degrees is 1/2. So we ended up with the same value, and we got it right. The next two examples are going to work with the exact same formula, but they're coming from a different direction. So here I have to actually find the sine and cosine of these other angles. So S and T are representing angles, and both of these angles are located in quadrant 2, as they've shown us. So I'm going to draw a picture for each of them. I'm going to draw angle S over here in quadrant 2, and I'm going to draw angle T in quadrant 2. So then I have to assign my cosine of S to be -1/5. So that's 1 over 5, where the adjacent is -1 and the hypotenuse is 5. So I will have to do something to locate the other value, because I do need the sine of angle S, and I will need the cosine of angle T. So here, if I put these values on, I have the opposite to be 3 and the adjacent to be 5. So if I look at S first and I start to think about how I'm going to find the missing side of the triangle, I'm going to use the Pythagorean theorem to find this value. So I have -1 squared plus y squared equals 5 squared. When I subtract the 1 squared from the 5 squared, I get y squared equals 24. And I take the square root of that, so I get the square root of 24, which will simplify to 2 root 6. Well, it actually simplifies to both positive and negative 2 root 6, but because my y is in a positive direction here, the value that I want is the positive 2 root 6. So my sine of angle S over here, the sine of angle S is 2 root 6 over 5. Moving on to the other triangle. This one turns out to be a nice Pythagorean triple, and I end up with 3, 4, 5. So I might not need to use the Pythagorean theorem to find it. If you do, no problem, you'll end up with 4. But my answer as stands is wrong, because this is in the negative x direction, so my value should really be -4. And that tells us that my cosine is -4/5. So I've got everything I need. I've got my cosine of S, my sine of S, my sine of T, and my cosine of T. And those are the values that I'm going to substitute into my formula. So to find the cosine of S plus T, I will have the cosine of S times the cosine of T plus, minus for this one, the sine of S times the sine of T. And if I substitute those values in, the cosine of S is over here at -1/5. Cosine of T we found over on this side to be -4/5, minus the sine of S is 2 root 6 over 5 times the sine of T, which is 3/5. So I'm going to multiply those values together. That gives me +4 over 25 minus 6 root 6 over 25. You're able to combine denominators here, but I will accept this answer. So we would repeat the same process with the cosine of S minus T. But the process is much shorter because I actually have all of those values, and the only difference in my formulas is that this turns to a plus sign, which means my final answer turns out to be 4 plus 6 root 6 over 25, or them separate. There we go. Let's try the next one. I've used a lot of red. I'm going to change colors. Alright, so I'm going to draw my triangles again, but this time it tells me that S is in quadrant 2 and that T is in quadrant 4. So here's my triangle in quadrant 2, and I'm going to draw quadrant 4 over here. I'm only going to use one axis because they're not in the same quadrant. And let's get some labels going here. So let's use sine of S over here is 2 over 3, and T is -1 over 3, my hypotenuse. So I need to find my other values. And I'm going to use the Pythagorean theorem on both situations. So my Pythagorean theorem for this triangle will be 2 squared plus x squared equals 3 squared, which will be 9 minus 4, or negative square root of 5. And I'm using the negative because it's in the negative x direction. So that makes the cosine of s equal to negative root 5 over 3. Sine of s, and now I have the cosine of s. Let's do the other one. The Pythagorean theorem on this one is negative 1 squared plus x squared equals 3 squared. So this one's going to be the square root of 8, and the square root of 8 is 2 root 2. I'm going to use the positive one because it's on the positive x-axis, which makes the cosine of t equal to 2 root 2 over 3. Alright, ready to go ahead and substitute these into my formula. So I will have cosine of s plus t equal to the cosine of s cosine of t minus sine of s sine of t. And now I can substitute in the 4 values that I have. Since I have the sine and cosine of both s and t, I'm ready to substitute them in. The cosine of s is negative root 5 over 3, and the cosine of t is 2 root 2 over 3, minus the sine of s is 2/3, and the sine of t is negative 1/3. When multiplying the numerators together, I'm allowed to combine the radicands. That's the number under the radical using multiplication. So I get negative 2 square root of 10 over 9 minus, that'll become plus 2 over 9. And that is my final answer for adding them. Because the only difference is that we will change the symbol in the middle here. That means that when I choose to use cosine of s minus t, and I want to find the difference in those two angles, I will end up with negative 2 root 10 over 9 minus 2/9. And that's my other answer for this problem. Please make sure you go back and review any parts of the video you didn't understand, and that you bring the worksheet with you tomorrow to class.